So pick literally any number, like any number at all. Now square each of its digits and add them up. Take the new number and do it again and again and again. Every single number you could possibly choose, no matter how big, eventually ends up trapped at exactly one of two numbers. Either it spirals down to 1 and stays there forever, or it locks into a loop and always passes through 89. This is Project Euler Problem 92, and I gave it to the same four models: ChatGPT, Gemini, Grok, Claude, with no hints, and all four got the right answer this time. But the way they got it there tells a lot more about which ones actually understood the problem and which ones just powered or brute force through it. Here's exactly how it works. Take any number, say 44, 4 squared is 16, 4 squared is 16, so 16 plus 16 is 32. Now take 32, 3 squared is 9, 2 squared is 4, so 9 plus 4 is 13. Take 13, that's 1 plus 9, which is 10. Take 10, that's 1 plus 0, which is 1. And once you hit 1, you're always stuck at 1 forever, because 1 squared is just 1. Try another number. Let's say 85. 8 squared is 64. 5 squared is 25. So 64 plus 25 is 89. And 89 leads to 8 squared plus 9, which is 145. Which leads to 1 plus 16 plus 25, which is 42. Which leads back around to a loop that always returns to 89. So no matter what number you start with, you always end up at 1 or 89. There's no third destination ever. And mathematicians have actually proved that. The question is, out of every single number below 10 million, how many of them end up at 89 instead of 1? And the answer is way more lopsided than most people guess. So Grok's solution was completely correct, but it did something a little unusual along the way that ended up costing it time. For every single number from 1 up to 10 million, Grok computes the digit square sum chain step by step, and while it's doing that, it keeps a running set of every number it visits during that specific chain. Now here's the thing. That visited set is never actually used for anything. It's not checking for cycles with it, it's not catching results with it, it's just quietly building up and storing values as the chain runs, number after number, 10 million times over. So the logic is airtight and the final answer is obviously correct. But that extra bookkeeping, tracking a set that never gets read from, adds a real overhead across 10 million iterations. And it's the kind of thing that looks careful, safe code that seems to prevent errors, but it's actually just dead weight, like weighing the program down for no reason. Grok's approach ended up being the slowest of the four, and it's a good reminder that being thorough and being efficient aren't always the same thing. This is where ChatGPT found something the other three completely missed. We're checking numbers all the way up to 10 million, which has 7 digits, and here's the question ChatGPT actually asked itself. What's the biggest possible digit square sum you could ever get from a 7-digit number? Every digit maxes out at 9, and 9 squared is 81. So 7 digits, each maxing out at 81, gives you a hard ceiling of 567, obviously. So here's the clever insight. No matter how big your starting number is, after just one single step, you're already down to a number 567 or smaller, which means you never actually need to compute chains for 10 million different numbers. You only need to solve the problem once for every number from 1 to 567, and then pre-compute whether each of these ends at 1 or 89 and store the results. Then for each of the 10 million starting numbers, you just do exactly one digit square sum calculation to shrink it down, and then you look up that answer in the pre-computed table and just compare them. So instead of 10 million full chains, ChatGPT computes 567 full chains and then 10 million single lookups. And that's the difference between grinding through the whole problem 10 million separate times and solving the small core of it once. And it shows that ChatGPT did this one cleverly and faster than anyone else. Gemini's approach is also completely correct, and it's built on a smart idea. It just doesn't go as far as ChatGPT's. Gemini uses memoization, which means it keeps a cache, a dictionary that remembers the final answer for every number it has already solved. So when it computes the chain for a new starting number, the moment that chain hits any number it has seen before, it just pulls the number straight out of the cache instead of continuing the calculation. So it's a similar logic to the ChatGPT 1 through 567, but it arrives at that through solving all of them rather than initially coming up with the idea. And there's a cost to this approach that ChatGPT doesn't have. Every single number, big or small, gets its own entry in that growing dictionary, and checking and updating a dictionary 10 million times carries a real overhead in Python specifically. ChatGPT sidestepped that entirely by proving upfront that it was just 567 entries, not millions. So Gemini lands in a solid second place, smart catching, correct answer, but without the extra step of coming up with that idea before the initial solving. So this is a rare one because Claude of all four is one of the only ones that didn't bring any cleverness to this particular problem. Claude's solution is honest, straightforward, brute force. For every number 1 to 10 million, it just runs the digit sum square from scratch, step by step until it lands on 1 or 89, and then it moves to the next number. No caching, no shortcuts, no bound on how large the intermediate numbers could get. To be clear, obviously the logic is correct. It checks every number, it computes every chain correctly. There are no arithmetic issues, obviously, but it doesn't do it cleverly. It's also the solution that you'd write about in 30 seconds without thinking too hard about it. There's no reuse of previous work, and there's no insight into the fact that every chain collapses into a tiny range after just one step. For a model that found the deepest insights in some of our past episodes, this is the time it just did the job and nothing more. And my suspicion is that it's due to the fact that these calculations aren't actually that hard, and for a model as large as Claude, they seem trivial in nature and seem like the easiest approach rather than coming up with a more unique idea. So let's put all four side by side. ChatGPT proved that after one step, every number shrinks to 567 or less. Pre-computed that small range and then looked up the rest. Fastest by a clear margin. Gemini cached every result it computed along the way, avoiding repeated work, which led it to a solid second place. And Claude ran a clean, honest brute force with no shortcuts at all. Correct, but like not remarkable in any way. And Grok did the same brute force chain, but it built a tracking set that it never actually used, so it just added pure overhead for nothing, the slowest of the four. All four landed on exactly 8581146, but only one of them figured out why the problem was small in the first place. Winner in this case is ChatGPT, and it did earn it with the sharpest read of the problem. Every other model treated this problem as 10 million numbers, but ChatGPT realized it's actually a problem about 567 numbers because that's the ceiling every chain collapses to after a single step. And once you see that, the rest is just bookkeeping. That's the kind of insight that turns a huge problem into a tiny one. Gemini takes a strong second. Memoization is a real valid technique, and it is something new that I learned through this exploration as well. It saved a lot of repeated work. It just didn't take the extra step of proving how small the cache actually needs to be. So it carried more overhead than it had to. Claude lands third, and there's no shame in it. The logic is correct. It's the plainest way of solving the problem, and in this case, it might have actually been more efficient for Claude particularly. And the answer to Project Euler Problem 92 is 8,581,146. And out of almost the 10 million numbers, just below 10 million end up at 89. That's over 85%. Almost every number you could pick ever funnels to the same loop of going through 89. Same four models next time, and obviously a different problem.